Can somebody confirm if I'm audible?
Yes.
All right, thank you. Right, welcome everybody. Thank you so much for joining in for yet another our training session hosted by rstats Club in collaboration with ABRIR. I'd also like to thank the Society for the Improvement of Psychological Sciences for supporting this endeavor. So during this session, we would be trying to learn how to carry out mediation moderation analysis using R. Before that, I'm Munna. I am a core team member of our rstats Club, and I'm more than glad that you guys have joined in, and I cannot wait to get started. So I hope everybody has received the R Markdown file, and I have also given an HTML document of the same that I think was shared over email. So while during this session, feel free to skim through the R Markdown and try to replicate the analysis with me step by step. If anybody is new to R Markdown, once you have R Studio installed in your laptop, you just need to hit this play icon that you see here, which will automatically run this particular code chunk. And whatever you see with the hashtag are the theory components or the comments that I've put, right? So we'll just get quickly started. So in this R training session, I'm going to run you through one of the most commonly used complex statistical technique that we use in psychological sciences and allied sciences, that is mediation moderation analysis. The prerequisite to understanding this session is to also know how simple linear regressions work or multilinear regressions work. Ultimately, we will be trying to do what is called structural equation modeling. I would try to make this as simple as possible if you are new to regression. So in terms of mediation analysis, at first, we would be, as some of you might already know, that what it helps us to understand the process in which like an independent variable affects a dependent variable through a mediating variable. 1 second, I need to let somebody in. Yeah. So like I said, it will help us to understand how an independent variable affects the dependent variable through a mediating variable. That is, if for a relationship of X impacting Y, like how does a factor M try to help us understand the effect of the relationship between two of those variables better? As in, does it link the two variables together? So what kind of role does that particular variable hold in this particular analysis? So ultimately, we would like to know that how much like this variable M can help us understand the change in the relationship that is happening from the dependent to independent or dependent variable and dependent to the mediating variable. So here, like for example, I have taken this data set called BFI. BFI is nothing called the Big Five inventory. It's the personality inventory that a lot of you might be familiar of. If you want to know more about it, okay, so the window might look slightly different in your screen. This is something personalized that I did. So wherever you see your console, I'm hoping you would see somewhere down here. So you just press a question mark and type BFI. And 1 second, I need to run this. So here, if you search BFI, you'll be able to get a little more details on what is BFI, what is the data set like, what all are there. So here, as you can see it, there are almost like 2,800 subjects included in this particular data set. And these are item-wise scores. That is, these are A1, A2, A3, A4, A5. These are the 5 items of agreeableness or amicability. Then similarly, we have the remaining 4 as well. So we have agreeableness, conscientiousness, extraversion, we have neuroticism, and openness to change. So this is one data set which does not have any raw scores or average scores as such. It just has the item-wise scores. You can just collate it together to make average scores later. So I'll be using that particular data set, and all the variables that I'm going to use are continuous in nature. So like maybe you might have been familiar with the effect of, let's say, gender on a certain kind of a relationship between variables, or socioeconomic status. Those are some binary or group-wise moderating variable or mediating variable that you must have come across. But here, for the simplicity's sake, I am going to continue with three continuous variables, and I'll not be doing this analysis on raw scores. I'm just going to pick one item from each of these subscales and run the analysis. So that is a big disclaimer that I need to give you. Some of the results that you see here might not be completely reliable, because this is just item-wise mediation moderation analysis that I'm going to demonstrate. Later, after this session, with the help of other packages like dplyr and stuff like that, you can, of course, try to collate the items together to make subscale scores and then try running this analysis. So that could be like an post-session activity for you all. And at any point, if you face any trouble, you can get in touch with us over our Slack group. So we will try to respond and help you out with any of the trouble that you're facing with running these analyses. So now we will just continue with the theory part of the mediation analysis. So like I said, this is what mediation analysis is. And in simple terms, what we will be trying to look at is we'll be trying to look at three different things. One is, how does the how does the path of regression look like from the independent variable x to the mediating variable? Similarly, we'll be looking at how does the path look like from m to the y while controlling for x. So x is the dependent variable, x is the independent variable, y is the dependent variable, and m is the mediating variable. And then finally, we'll also look at what is the direct effect of x on y when m does this. M is completely set control. And then we will look at a total effect. That is like, how does the direct path look? That is, direct paths are these. Uh, Direct path is this. And how does the indirect path? That is like combining both the direct and indirect, we will get a total effect. So first, this is the introduction to the data set, a little bit like what exactly I'm going to use. So I'm going to take the first item of these three subscales: amicability, which is also called agreeableness, then conscientiousness and extraversion. And this is the disclaimer that I just gave you all. So we will just start with loading packages. If any of these packages are not already installed, what you could do is you just need to type install dot packages. It will automatically come. You just need to put the name of this particular package in double quotes, and then you just need to run it. So I'm just going to put, because it's already done for me, I'm just going to run it in the console, and I'm going to hit no. Right. So once it's done, you can, when you just choose it from library dplyr, library site, Lavan, whatever libraries that we are going to use, it will automatically get loaded. So for people who do not really know about these packages, I'll just give an introduction. So the dplyr is a very stable package that you all need to use to do basic data manipulation. Here, the data manipulation does not stand for the unethical practice. Here, it just stands for collating groups, or like collating numbers, or renaming certain columns that exist in your data set, or clubbing things together, renaming things, or trying to create groups based on the values that you've got. So those are a bunch of things you could do in dplyr. Then we'll also be using the library called psych package. Psych package is a really good package which has a lot of statistical analysis, very simple and complex, as simple as descriptive statistics to multivariate analysis, everything you will get in psych package. Here we will be using the package called Lavan. Lavan is also a package that can be used for confirmatory factor analysis, even latent growth curve models. But here the reasoning behind using this package is to do structural equation modeling, which is very central to carrying out mediation moderation analysis. Then I'll be also familiarizing you all with the package APA tables. It's one nice package which would uh, convert convert whatever findings you get on your terminal, the results you find in terminal, into very sensible APA formatted tables and graphs. Not graphs, actually, only tables. Then Cable Extra is another package that I use. This is to go to the next step of tidying up the tables that is created via APA tables. Like, for example, converting the table into Times New Roman font size and stuff like that. So whenever you're trying to load a data set, you need to always put data, and in the bracket in double quotes, you need to put the data name. So here, one example is BFI. Another one can be data in the bracket. If you put cars, that's another data set that is there. Um, so there are many data sets that you could explore. I would really insist you all try different data sets and try running the analysis, so it will be easier. So once the data set is loaded, you can check what is the first few rows of the data set looks like, for which you could use a head command. And here you don't need to use the double quotes anymore because it's already loaded. And here you can see the first 1, 2, 3, 4, 5, 6 rows of the data. Here A1 is there, C1, and E1, N1, everything is there. Okay. So now we will get to the main part of the session. That is the first model that we're going to test. That is a mediation model. So here we need to first set up what a model is. So with here in R, what we need to also understand is we are going to, whenever we do any kind of modeling, we need to create the skeleton of the model. We need to tell the algorithm what exactly you are intending to do with the modeling. So when other platforms like, let's say, Jasp or Gemovi are being used, it's already automated in the background. It's also a point and touch click software interface. So things are a little more easier. It might seem a little more easier there, but here you will have more flexibility in creating the skeleton of the model and then running it. By feeding the data, you can run it as well. So here, first we need to here whatever paths we have defined, the 3 paths that I mentioned here, we need to manually create a skeleton for the model. So including the total effect, which I will explain one by one. So here we are going to assign the whole skeleton of the model to the word model. And here the direct effect is we are trying to look at extraversion. So here extraversion is a dependent variable and A1 is the independent variable, that is agreeable. So we are trying to see what kind of an effect does agreeableness have on extraversion? Like does it increase the propensity of your extraversion, or does it decrease it? Does it have no impact? We need to try to learn that. So for that, we need to also multiply the agreeableness values to a coefficient called C. So C is the when we say coefficient, it is nothing but a number which would give us the direction and the strength of the particular relationship. Here, since we are trying to look at the regression, it will be the coefficient of regression. If it's a correlation, you might know already the coefficient. It's like when it's a negative value, it gives negative correlation. When it's a positive value, it gives a positive value, positive correlation. So similarly here, the coefficient C is the regression coefficient. And next step is to define the next part of the model, that is to do with the mediator and the independent variable. So here the mediating variable is a consentiousness factor. So here we also need to put a coefficient, but since C is already put here, this is like the staple. When we do just one simple linear regression, we always go with just the letter C. But since we have multiple regressions to carry out, we need to distinguish between the coefficients as well. So here I'm going to put A for because it's agreeableness. So I'm going to put the coefficient as A. So then on the next step, it is going to be the other part of the mediation model, that is the mediator and the dependent variable. So here again the coefficient is set as B. So now we have A, B, C coefficients, where C is the coefficient which coefficient for the direction and strength of the direct effect between dependent variable and independent variable. A coefficient is the one for independent variable and mediating variable, and B is the one that is for the mediating variable and the dependent variable. So these are the 3 direct effects that we have got. Now to estimate the indirect effect, what we need to do is we need to get the product of the coefficient A and coefficient B, which is basically the relationship between independent and mediator and dependent. We need to try to find the product of that, and that gives us the indirect effect of independent variable on the dependent variable through mediating variable. So this will account for all the 3 variables together. Next, to do the total effect, Here we don't need to multiply anymore with the coefficient C, that is for the independent variable on mediator. Here what we need to do is just add the coefficient of mediator and independent variable along with the product of the indirect effect that we have got. So here we have assigned it to AB, and the word AB here, it's nothing but the assignment operator that we are trying to do here. And then here we also put total as a word for total effect. Once the model skeleton is ready, now we can feed the data into this model. So for that, we need to use SEM. SEM is a function used in, it's nothing but again, the structural equation modeling, and it is included in the Laban package itself. So here we put SEM, and we say model. Model is a skeleton that we created here. So we put model here, and then in comma, we also take which data has to be used and the missing values, what to do. So here I have chosen the ML technique. So ML technique is nothing but full information maximum likelihood method for handling missing values. This is nothing but telling the algorithm that whenever there's a missing value, it's most of a random missing values. It has nothing to probably do with the variables that we are trying to put in the model. It is mostly to it's quite unrelated, and the algorithm need not really worry so much about trying to find any link to the to different variables and the absence of the presence of missing values. It has nothing to do with that. And when we say ML, we are also trying to estimate the missing values by we will create an estimate based on whatever value we have gotten, and we will just try to replace it whenever the values are missing. So it's kind of a technique to handle the missing values. If you do not want to do that step, you can also remove this chunk of the code and it will still work fine. But when I have tried to make this code, there have been a bunch of missing values, and it did. I had to troubleshoot this to understand that there is some way you need to handle for missing values. But do not worry, once you are trying to average different items together as a row score and try to do this, then the missing value problem might not be a thing because you'll be putting a zero whenever there is a missing value. Or if you want to still account for the missing values, you could always use the ML technique as well. So once that is done, it will give you some results in the console, something like this. It is very confusing. I'll just try to open this on full screen, and this is so confusing, and it partly shows the values, and you can't even scroll down. So for that, we need to convert this into a very sensible format. So when you do, so whatever I just showed you, these values and results that we have gotten, it happened because of the summary function that we have given. Here we have already assigned the result of the model into to the words fit. So now we need to find the summary of summary. We use a summary function to find out the values correctly. So when you use a summary function, it automatically would collate the information into one sensible fashion. It just extracts it and put it like this. But still, this is not very usable. So what we need to do is we need to extract these values correctly and make it into a sensible table, something like this. So the next chunk of this session is going to be about teaching you guys to how to use APA tables and cable extra packages to make a very clean APA formatted table like this. So for that, first we need to extract the values out, for which there is this function called parameter estimate. It's already there in the Lavan package. And here again, like whatever we have entered for summary here, it's the same thing. We try to put fit standardized is equal to true. We want to get the standardized value. There are also unstandardized values of coefficients and estimates that you might get, which we do not want. So we are trying to tell just only display the standardized values. And then we need to, this is where we are going to do a little bit of data wrangling. So here, what we are trying to do is we are trying to only take the information from this big giant result that we actually need for reporting our data. So here we are going to tell which are the columns that we need. So not the columns here because it's not a table yet. So whatever the parts of the information that you really need from that results page. So here I need this something called the LHS, the left hand side. I also need OP. I need the RHS, the right hand side of the information. So here you can see left hand side, right hand side, and the intercepts And I need the standard error value, I need the estimate value, I need the Z value, P value, confidence interval lower and confidence interval upper. And once you extract this much part of the findings, now I want to filter it such that whenever there is an approximate sign and whenever there is an equal to and double colon sign, we need to pick those. I will tell you why we have done that. So here, if you see it, when we created the model to distinguish between all the extra bit of the information that we really don't need, we have used approximate sign for direct effects, and for indirect effects and total effects, we have used this particular as a distinguishing operator. That is the equal and the double columns. So but we are trying to filter that whole data set based on the presence of these two operators. So that is why here we have also included the operator sign, operator component of the results. Once that is done, using the cable extra package, I'm trying to do a little bit of cleaning. Here, if you see it, you can see like three decimal points here, which is a good sign. But whenever you try to do a proper, when you try to run this with proper data, you might get more than three decimal points. So what it will do is when you do KBL digit is equal to three, it will give you three decimal points, and it will also give you a caption option. So here I've given a caption of mediation analysis results. And here I'm saying full width on, I'm choosing the team cable underscore classic. And I'm telling to for full width is equal to false, F is equal to, F means false. We can also type it completely as false. But here, when you say F, it means that like you are not going to elongate the whole columns. Just adjust the column such that whenever the text is there, wherever it fits, just stop the column width there. Do not need to expand it into a very big column. So it will not give it in full width. It will give you in like normalized width of like different columns. And for the font, I have chosen Times New Roman. You could also use Arial and other fonts as well. Arial and Times New Roman are the only two fonts that I'm familiar with this particular code. But you can definitely Google if there are any other fonts that will work like Georgia. Now that I think about it, I should also experiment it. Once that is all assigned to the word mediation table, you can display when you type mediation table, this is what it will display. I hope you all got that. Once this is done, we can also try to interpret the results. So here, I'm not going to get too deep into the interpretation of the results because it's already there on the R Markdown and it's pretty much intuitive and easy. But however, in short, what I could tell you is that there is a significant relationship between the independent variable and the independent variable and the dependent variable. So here you can see the p-value is 0, and there's no value of 0 in between the lower confidence interval and upper confidence interval, which again suggests that there's a significant regression coefficient that we could identify. And here the estimate is shown is 0.124. So when you say estimate is 0.124, it means that whenever there's 1 unit change in the variable that we have here, which is the in independent variable, the dependent variable increases by 0.0124 units. So that is what the estimate value gives us here. And and then the p-value, of course, tells us if it's a very significant prediction that we are able to make. And it also gives the ZZ value for other analysis and also the confidence interval. Next, coming to the mediator variables effect. In short, both of these were giving us positive value. Here we were getting positive value and here we were getting negative value. However, the point is that it is neither of them are significant in nature, which tells us that like the mediation effects are not significant. I really hope when you do it on your own data set or some other data set, you will get a significant difference. Here you can see there is an overlap of 0 in both these cases, and it's pretty much the same value for CI lower and CI upper, which suggests that there is no significant mediation that you could identify. And next, in terms of the here also we have estimate given, that is 0.24 and 0 minus 0.36. These are also estimates. That is, if it was significant, we could have used these values to tell like how much unit of change happens in the independent variable, so dependent variable and mediator when the independent variable and mediating variables are present, respectively. And when we try to do the, when we try to go to the next indirect effect here, it, like I said earlier, it calculates the indirect effect of indirect effect, that is the impact of the independent variable upon the dependent variable through the mediating variable. So this is one extra step. This is the step where we will totally understand if the mediation is significant or not. Obviously, because the other two direct effects were not significant, or if either one of them was not significant, we might not end up getting a significant mediation results. So that's exactly what has happened here. The p-value is 0.303. So it means that there is not a significant mediation effects, and the estimate value is also very low, although it's negative. And similarly, then we go to the conclusion section. I have clearly stated what are happening. So one is the direct effect of independent on dependent variable is significant, and it's also positive direction. That is like when A1 is increasing, the E1 also increases. That like when agreeableness increases, there is an increment in the extraversion component as well. However, when it comes to testing for indirect effects of mediation effects, we did not find anything to be statistically significant. And when we check for indirect effect, obviously the effect of C1, that is the mediating variable, was very small, but it was not significant enough. And when we try to do the total effect seems to be significant, which also suggests that like there is a difference in terms of like how the direct effect functions, because direct effect is coming significant, but the indirect effects were coming. Direct effect for really independent and dependent was coming as significant, but the other two was not. And similarly, indirect effects were also not coming significant. So that is about mediating variable. If you have any doubts regarding mediating variable mediation analysis, I would love to take the questions right now.
There are some questions in the chat.
All right, thank you so much. Could you please explain the logic behind calculating total path? And why does A into P give total indirect effect? All right. So basically, for the first question of explaining the logic behind calculating the total path, we would want to ultimately understand, like, so basically here you have noticed, right? In the first direct effect, we got a significant result. In the second, when we try to do the direct effect, let me go back to the table. So here we got a significant result. So this is the basic structure of the equation. I think somebody's trying to join. No? Okay, no. Yeah, so in the first equations, modeling for dependent variable, we were able to identify that there's a difference. I mean, sorry, there is a significant regression happening, and there is a significant relationship between the like significant prediction of the independent variable, independent variable upon dependent variable. So we are able to definitely establish that the basic structure of the equation is right, as in like it is significant, and there's actually some impact that the independent variable has on the dependent variable, right? Then when we try to do independently, how does the mediating affects the independent and mediating affects the dependent variable, there things are getting a little diluted. So we are trying to track the path of the mediation cycle. So in like if the in the absence of the mediation model, we are able to find something. The mediation variable, we are able to find something. But in the presence of mediating variable does not seem to directly seem to like predict the dependent variable, or independent variable is not directly predicting the mediating variable, which kind of dilutes the overall model. And we want to also estimate how much of a dilution is happening to the overall model that we have just pictured. When we try to do only A into B, we are trying to only estimate uh, how does the mediating variable, independent variable and dependent variable change based on the mediating variable. But in terms of the absence of the mediating variable, we are not able to account for it along with it. So we will try to add both the indirect effects and direct effects to understand an overall picture of how the model functions. So the first, these are like, however I have put it, that's the step that you need to follow also. First, you need to establish whether independent dependent is related. And then you need to see how the mediating is affecting, like how independent is affecting mediating and mediating is affecting the dependent variable. Then we need to see in the presence of, like how does the path look like if it's the A to M to B. So sorry, X to M to B. X to Y. So you need to understand how the path looks like. Then you need to account for all the three possibilities like X to M and M to Y, and also from X to Y. So all three together comes as a total effect. And just above one is just for the one from independent to mediating and mediating to dependent. I hope that's clear. And what was the second question again? The second question was, why does A into B give the total indirect effect? A into B does not give the total effect. A into B only gives us the indirect path of like involving mediating and moderate, mediating and independent dependent variable like I mentioned. It does not account for the direct coefficient between independent to dependent. It doesn't account for that. So I think there was a confusion. I hope that's clear now.
Maybe you can repeat again the all paths. What is A, B, and C? So just to repeat it so that it's clear.
All right, sure. So let's just go to this section. So here you see, I'll just try to do this in a little more simpler fashion. So we are trying to see that, let me just write it as it is. Okay, so we have um, independent variable, and we want to know how it affects the dependent variable, right? So this is the very basic thing we need to know. Like if this does not, like if this particular part of the equation does not come significant, then there is no point in the whole model because at the first place, there is no relation between the two variables, right? So this one is being estimated by the strength and the direction of it is given by the coefficient C, right? But now we need to also know independent, how does independent relate to the mediator? And similarly, we need to also see okay, my spelling is wrong, but do not really bother that. Then also we need to see the mediator to independent. Yeah, so here, this one is being given by, let's say, coefficient A, and this one is given by coefficient B. So here, when you say indirect model, what we are trying to see, when you say total model, we want to account for all these possibilities like A and B and C. So the addition of C plus A into B, that is like they basically like what is the relationship? We need to get the coefficient of that. What is the relation between independent and dependent? That coefficient we need to get C. That along with the indirect effect. Indirect effect is independent leading to mediator. What is the relationship like? Then the product, the same thing, but the product with mediating and independent. So this will, when you say indirect effect, you are only trying accounting for these two. But the moment you are involving all three of these coefficients, you are trying to understand overall how the model looks. Understood? I hope now that's clear. Now that I put it as words clearly, I think this is a little more clear. So these two, once again to repeat, these two only give us the indirect effect. Like is how does the path look like? Independent to mediator, mediator to independent. It doesn't account for the independent and dependent one. So like what is the basic relationship between the two? It does not account for that. Here, when you're trying to do the indirect path, we are only trying to see whether we are trying to see whether the mediation effect is coming properly. Like that is the mediation effect actually exists. If any of this parts, say in our current example, this came non-significant and this also came non-significant, but this came significant. So here, when you are trying to find the product of these two, you definitely will understand that there is no relation mediating effect at all. But the moment you include the significant basic equation, you also will understand that basically there is a relationship that exists between the two. but just that the mediating variable does not seem to have affected this relationship. So this is like if you are familiar with ANOVA, like when we do ANOVA, we try to get an R value, an R square value, right, to understand how much good the model is. So similarly, when you do each of these, like individually, the findings of these three things would give us their respective regression results. Like that is what is the effect of independent on dependent, independent on mediator, mediator on independent. The moment you involve the coefficients and try to calculate the effects, when you include these two alone, you just get the mediation effect. That is how these three things are connected. But it will not give you the whole idea, whole picture of it. To get the whole picture of it, you also need to calculate the total. But why does it not make sense to test for mediating effects if C is not significant? B should mediate. Okay, why does it? But why does it not make sense to test for mediator
No, I
effects?
just asked, first of all, I think the B should be mediated to dependent variable and not independent as you have written it.
Can you point out where exactly
Yeah,
that ever happened?
31. I don't think it's like, you deleted it now. Okay, doesn't matter.
Yeah. Okay. Uh,
Wait, sorry, no,
yeah,
sorry. Could you
yeah,
reverse, like, no, reverse what you just deleted?
yeah, sure.
Because I'm lost here. See, line 31, mediator independent. Should it not be mediator dependent?
The last one that you're talking about the last one, right?
Yeah.
Independent to dependent, independent to mediator, mediator to dependent. So here so here when we're trying to do it, we are trying to. Oh yeah, thank you so much for pointing that out. Yeah, yes, that makes sense. When you're trying to decode what exactly you've written, it sometimes is really messy. Yeah, thank you so much for pointing that out. Now this makes more sense, I think.
Yeah, thank you. And my question was to 27, because line 27, you said that it makes no sense to test for mediator effects if C is not significant. And why it makes no
Yeah.
sense, I just don't understand it. Thank you.
Yeah, right. So basically, the thing is, let's take a very simple, different example. Okay, let's say the independent variable is stress, and dependent variable is well-being, right? So it's a very obvious thing. Like lot in most of the cases, we will also know how stress does have an impact on well-being. But once like so, when we are trying to test for any kind of mediation or even moderation, our assumption is that we want to see how relationship between two variables are impacted by the third component. So if the A and B does not exist, like the variable X and Y does not seem to be connected, then there is no point in like us trying to do a mediator effect, right? So instead, if let's say if we have multiple variables, let's not think about mediation in independent or mediating variable. Let's just try to think that we are trying to test multiple simple linear regressions. Let's say stress. How does stress impact the well-being? Let's say how does parental support impact well-being? How does your physical health in some factor impact well-being? So when we're trying to test multiple things, here there's no point of there's no thought of mediation moderation. Here we are just testing how does each of this depend. So similarly, when we are trying to do a mediation analysis or moderation analysis, if the basic relationship does not exist, such as let's say physical health to well-being, let's say if that relationship does not exist, why would you go for the third variable? Let's say um, how does the what was the other variable that I mentioned about? I think the parental support. Maybe the parental support might impact only the dependent variable, let's say, but it does not have anything to do with stress. I mean, these are all cases of significance, which is not a very good thing. Like when we are trying to do data-centric, data-driven approach to doing statistics and univariate statistics, that is a very big problem. When we say like stress impacts well-being, we might think it's a very obvious thing, but depending on the sample size, the testing size, and all those things do seem to uh, change and get like messy a lot. So in that case, like if the independent and dependent are not related, there is no third variable being tested. That makes sense. Is that is
Yeah,
this a better explanation?
yeah, thank you so much. So would you advise then to first test, run a simple regression to see if independent and dependent variable, like says there is a significant relationship, and only then add a mediator into the model?
Yes. Yes.
Okay, yes. Thank you so much.
Yeah.
Sorry,
This is again, yeah.
I had a follow-up, but finish.
Yeah, go ahead.
Oh, okay. So I understand that logic when it comes to moderators, because they might change the strength or the direction of an independent variable to dependent variable association. But when it comes to mediation, in theory, at least, the independent and the dependent variable could in fact be not related at all. And the mediator is what affects that relationship, no?
Okay, maybe I might want to check on this because as far as I'm aware, it's the other way around. As in like the factor that let's say we'll go to the moderating component next, but let's say like a moderating effect of gender, uh mm, like male and female, then the effects for those two would be different, right? I mean, like because you have two different data, so let's say male and females, the models are two different things. As in, like for one population, you have one model, and the other population also you have other model. I mean, that is just if you're trying to break down into two different models. But if you're testing it as one single model, because the data itself gets separated into two based on the moderating variable like male and female. I think the independent dependent relationship can be different. For example, let's say like in case of let's say something very obvious, that example that I can come up with, like for example, prenatal prenatal stress that women face and prenatal stress faced by men as like fathers and mothers could be definitely different when it comes to their impact on well-being, right? I mean, it is just a very common, very logical thing that I'm making, but this might be not this might not be really empirically driven example that I'm giving. But for these two models, it will be different, right? I mean, like it might not really have an impact on men as much as women. So I was under the impression it's the other way around, but I think I need to check on that once. You could be also thinking that way. Yep, this had the same doubt. What if the mediating variable has a role in the lack of relationship between the two? Um, that I think I'm not really sure. I think I need to check that because I was thinking that about the moderating variable, not the mediating variable.
I had a question.
Yeah.
For the total effect, why did we multiply A and B and then add it to C instead of adding all three?
So when we say total effect in simple terms, it's like direct. What is a direct effect like combined with indirect effect? So since we have two models here, we try to get the product of the two. And here, since this is the like this is the product of these two gives us the indirect effect, and the direct effect between the two is there. So it's better to just get one number. So I don't know why we product it, but I think it's to get one single number representing both. So the product of two components which give us the indirect effect plus the direct effect of like the x and the independent dependent variable.
Okay, I was kind of trying to understand the reasoning behind why we're going to multiply those two, but I'll
Right.
I'll look into that.
Yeah, sure. Yeah, so regarding this doubt, ChatGPT says if there is no significant relation between independent dependent variable, running a mediation analysis is not generally recommended unless there is a strong theoretical justification. Yeah, so okay, so then that's in that case I was right. But you might want to test the same thing for moderation also because Just test for this, test the same thing for moderation as well. Because like I said, with the gendered example, I think that's the case. So basically the thing is whenever, let's say, like I said earlier, when there are a list of variables that are involved instead of like three variables that you're doing, right? We have the variables. We are trying to do different simple linear regression, right? We are trying to do a series of simple linear regression to come to a conclusion whether uh, these variables are related. And if yes, how does the presence of this variable impact the relationship between these two other variables, right? So that is what we try to do. And like I said, often, as much as I'm making examples with obvious things like stress and well-being, there are moments wherein like stress and well-being, I don't know why it might not come significantly predicting the stress does not significantly predict well-being in certain population. We never know. That could be also because of the data distribution. The data must be skewed or like having some or having very less data points to compare with. Due to so many reasons, that might not be the case. As much as it might not be logically sound one thing, but but here in the case of stress and well-being, it should make a difference, right? It like stress should definitely impact our well-being, right? So in that case, like the response said here, theoretically it should make sense, like to have a relationship. So in that case, you can just probably run the mediating role and see if it helps. But again, then you might have to question the legitimacy of this test. So I'll be brutally honest here. I have been somebody who I've been somebody who always did univariate statistics, and I had always loved doing that. But as soon as a lot of these different variables like data size, the skewness, the data distribution, everything seems to like pool in and chip in together to make a very sensible decision. It sometimes asks us to take some trade-offs and then do the analysis and probably take the results with a pinch of salt. So because of which I have been curious about multivariate statistics more recently. That's a little more complex, and I don't want any of you to try it if you guys are new to univariate itself and regressions. But that's something personally a journey that I'm taking currently with multivariate statistics, which also includes confirmatory factor analysis and stuff like that. So I think it's a good time to go to the next bunch of the analysis. So here I have kept the basic structure same. That is the independent and dependent variable remains the same. Just that the moderating variable I've changed to respond another component, that is neuroticism. So here we need to do one extra step of data wrangling because currently in the column we already have A1, N1, and E1. We also need to make an interaction term called A1 into N1. A1 here is the independent variable, and N1 is the moderating variable. So we will create an interaction term, and this is done to capture the combined effect of the independent upon moderator and like how the combined effect, how does the independent variable impact a independent variable and moderating variable impact on the dependent variable. So it's just like rather than considering this as a triangle, right now you need to consider it as like inverted triangle. So here you're trying to see how does moderating variable impact the dependent variable and how does the independent variable impact the dependent variable. So it's like earlier considering the full kind of, oh my God, let me make a triangle. Okay. How do I make a triangle? Yes, if instead of making a triangle, if you assume this is a triangle, earlier we were doing this, but now we have to flip it. Now we are not caring about these two things, like the independent to mediating, sorry, independent to moderating. We're caring how does a moderator impacts the dependent variable and how does the independent impacts the moderating variable. So here in the interaction term, here in the interaction term, we are finding the product of independent and moderating variable, and we will test that as well. So we will independently test how does the moderating variable impacts the dependent variable, how does the independent variable impact the dependent variable, and we also will also test how does it combined like impacts the dependent variable. So we need to see does the presence of the moderating variable along with the independent variable have an impact on the dependent variable. That is as simply put. So here we will do that. So here when we do BFI and the function I use is mutate. Mutate is nothing but it will make another column the first term, this is going to be the column name. And what you need to do is call A1 into N1. The product of independent and moderating variable is what you need to put under this column is what we are trying to say here. So now if you see BFI here at the end, you will also see the product of A1 and N1 and their respective values underneath this. It's almost 2,800 subjects data. It's pretty fast by R to get it done. So here things are a little more simple. Now that we have done uh, the model already, we have already created, we don't need to create a new model skeleton because the model skeleton already exists above. If you want to create a model skeleton from scratch, because imagine you have never done a model for mediation, we did not do mediation first. You are not even thinking about doing mediation. But I would always recommend trying to do mediation whenever you do moderation, or try doing moderation when you're doing to mediation also. Because we need to always rule out the other possibility. Maybe one of them will end up working out. It's not a very good approach. It's still you would want to rule out the other possibility. If you're doing one, then might as well do the other thing to understand does it have the other kind of effect than you expected. So here in moderation model, we are just going to do a very simple LM model. And here we are trying to see, so instead of, this is one way to do it. That is, you already create a A1 N1 compound like column and do it. Otherwise, you can just directly do this as well. So I was just trying to display two different ways to do it. If you want to skip this and just do A1 A1 N1. This is also something that you could do. But otherwise, you could just explicitly mention like this as well. Going back to this. So explicitly you can mention this. So this will, I think this will be a little more clearer for you. But if you want to test for the product before even trying to run the model, this would be the best way. You'd already try doing this once. You see how the product looks. So here you can see like there is a huge variety of numbers that you could see here. So this is, again, here there's an NA value. I think some missing values are there. So here we are trying to do a simple linear regression. How does this impact? And then when you try to run the summary function, it will this will generate the summary. So this is the summary that would see. It's pretty much similar to earlier. So this one automatically gives you the A1. How does A1, that is the independent variable, impact dependent variable? How does the moderating variable impact on dependent variable? And it would also give you how does the interaction term, like the presence of both, give a change. So from here, you can clearly see that the independent variable dependent variable connection exists, but the other two doesn't exist. Neither does the moderating variable independently, nor does the combination of independent and moderating variable seems to have an impact on independent variable. So I think moderation analysis is a little more easier to understand. And then this is again creating a new table. I would love for you to try checking this on your own, how to create this table. Right, it's pretty much same as what I did for mediation with very tiny little bit change, except with the way in which we're extracting it. So here, if you see it, I have used a broom package, but if you go to the mediation analysis section here, you could see I have not used the broom package. Instead, I have used cable extra and I have used API tables. So try doing this. I think this will be fun activity to do because always we end up, me included, I end up doing analysis in R, and I end up not using API tables quite often. But I really insist we all switch to that, including me. This is also a suggestion for myself. I also need to start using API tables quite extensively because it makes everything clearer and transparent in one single page. And the interpretation, of course, the basic, this particular first bit stays the same because it's same as a mediation analysis thing that we did. There's a significant impact here, but there is, and there is also a statistic value, but there is no significance for these two. So it doesn't really moderate. And here we will not be calculating any of the effects because it's pretty clear. Like here, we are trying to do three different in any linear models, simple linear models, and try to see. The other place we would really need to try to see the combination of things, not the combination. We need to see how does the three-way pattern looks like. Here we don't really have a problem with three-way pattern. Here we are only checking if the presence of each of these things, like independent and moderating independently try to do something, or does a combination of both try to do something? So this is a little more simpler to understand as well. Yep. And there's also some references mentioned. The first one is really old, but I think this is the one of the most pillar stone of mediation moderation analysis. This is a very good article that you could read. Then the second one is a haste method. So there's also another method also called the haste step. That's also something that that kind of helps us uh, try to do mediation analysis mostly more than moderation in a very stepwise fashion. And there's also this R in this R markdown you in a way you try to understand how hierarchical regression modeling works. There is a lot of ways to do it, and there is no one single code that will sorry, there's no one single code that will get everything done. It's always about playing around and trying to see how different codes help us understand things better. So yeah, that's pretty much it. Um, now I think now that I'm done, I think I can take questions again if there are any. Otherwise, we could end this session. And always feel free to ask us questions over email or our Slack channel, if at all there are any after the session is done. And anytime if you face any trouble, we also have a troubleshooting channel under Slack, so we will be also responsive there. And bear with us if there is any at least a good if there is like a 24 hours delay, but it will not take more than that. We already have team members who are constantly checking Slack.
I don't know if you can answer, but thank you so much for your session, first of all. And I wanted to ask you, I sometimes try to compare the results between R and JASP, but if I have categorical variables or binary variables, it depends a lot on the contrasts. Do you have any suggestions on how to approach this? Like, would you say just take what JASP suggests or what R suggests, or depend on your questions? I just find it's quite interesting that the default values are different and it can confuse the users.
Right. So basically, like I said initially, like in R, we are trying to create everything from scratch. So whatever, so R thinks that it's completely blank slate, right? But on the other hand, for platforms like Jasp and Jamovi, it's also engineered in a way that it pretty much makes it easy for you to do get things done. So the contrast that you're talking about, I have never used JASP for mediation moderation analysis. Earlier, like when I was in college, I was using SPSS. But after I graduated, I've been using R. So I think the best thing is with R, I think best approach is to go with R because if you want to add a contrast, I think you can add it, but I'm not really sure how to implement that into the code because right now here I showed using LM and I also showed using Lavan. I don't know which of these two packages would have a plugin for contrast. That's something that we need to check. So if either of these techniques have a contrast plugin and you want to adjust the contrast, you can do that. But otherwise, since right now, whatever I followed, I have not added a contrast term to any of those codes because here we are trying to just introduce like what is a basic structure of mediation moderation analysis and what are the different packages which supports this kind of an analysis. So if you want to plug in a contrast, we want to check that. But I from a this is from a technical, like a software slash platform point of view, like what is better, I would say R. Because at least that will give you transparency in terms of when you're reporting your results, you can be transparent that you did not have a contrast term into the code. That way you will be feeling a little more open about what you have done. But in terms of like a suggestion in terms of whether to include contrast or not, maybe I'll be the wrong person to ask this. I think it also depends upon the variables that you're testing and the sample size and the data distribution, like how much variance you see and stuff like that. So the contrast is ultimately to account for all these different things that you have got in your data. So I think it's more of a holistic decision that you might need to take and based on your data.
Okay, thank you so much.
No problem. So I think we can stop here. If there are any questions, like I said, please do email us. Please do feel free to reach out to us on Slack. And I would really insist you all keep in touch with us and keep checking us on Blue Sky. We have recently moved from Twitter to Blue Sky more. Not that we are absent in Twitter, but our updates are more prompt in Blue Sky. So if you have not followed us there, please feel free to follow us there. And check us out on our website if there is any resources that interest you. If you have any queries, feedback, anything, please feel free to email us. Let us know over Slack. And once again, thank you so much for joining in. And if there's anything that I couldn't really answer, I'm pretty sure my core team members, my colleagues can answer that better. And meanwhile, I would also try to see the questions that were asked. I think there's one question that was put up in chat. From a theoretical and R POV, everything was crisp and great. If any doubts, okay. Thank you so much, Saad, and the feedback. Yeah, please let us know if there's anything else that we could do. And if you have any suggestions for things that we could do, if things that we should do better, things that we should try doing something new. If you're people who have been with us for a longer period of time, and if any change that we have made, it seems like you would want certain old things to come back, please let us know. We would love to take suggestions and advices. So yeah, that's pretty much it. And thank you so much for joining in once again. And this was one of the last sessions that we have got in collaboration with the ABRIR for the time being, and with the funding of SIPs. So once again, thank you so much for joining in. And I hope you have a great rest of the day, and based on wherever you are, good night or have a great day ahead. Thank you so much.